Hello, Madhura ma'am.
Madam.
Just
Yeah.
a minute. Yeah.
I'm just sharing the YouTube link. Can you please forward it?
Will you present your screen and just show me if it is possible?
Yes, I'm just.
You can switch off your camera if you want some better speed.
Yeah.
Yeah.
Can you see the screen now?
Yes, yes.
Yeah.
Yes,
1
ma'am.
minute. Can you see more over here?
Yes, ma'am.
Yes. So I just clicked it, and then
I could see your YouTube window, not the first one.
Okay, 1 minute. 1 minute. Just a minute. It's getting problem to return back to the. Okay. If I share this screen, it is giving problem. It is giving me some problem.
Okay, ma'am, you continue then. You share it.
Okay.
I'll see that option later on.
Okay. Because if I share the screen, I don't see anything over here.
Yeah. Fine.
Okay.
Ma'am, have you shared the YouTube link?
I'm sharing the YouTube link. 1 minute.
Madam is sharing. Just wait for 1 minute.
Okay.
Today the speed is very less, so it is taking time.
We have started early actually, so we can try out.
You started a lecture early? Hello, you started a lecture early?
No, we'll start at 2:30 itself. We started the meeting itself, early, so we can wait at least.
Okay. So I've shared the link. Can you please share it with
Yeah.
others?
Yes.
And you can also start the recording. Probably I will be leaving the meeting. I'll make you the host. I think you are the host now, right now, or no?
Yes.
I'm going for the exam department for the further things.
Okay.
स्वाती मॅडम झालंय तुम्हाला होस्ट आता?
हो झालंय मॅम.
मी एक्झाम सेक्शन मध्ये जाऊन बाकीचे डिटेल्स कम्प्लीट करते. ओके.
Yes. Thank you.
स्टेपलर खराब झालं, पाडलेलं दिसतोय. काय सगळं माझ्या अंगावर
नाही चटणी खावला ते म्हणते चटणीला जसं समुद्र
सगळ्या स्टुडंटनी स्वतःचं माईक म्यूट करायचा आहे. वैष्णवी आमले ऐकायला येतोय का स्वतःचाच आवाज मीटिंग मध्ये तुला? म्यूट कर.
We are waiting for some minutes now, ma'am.
Yes, yes. We'll start at 2:30 exactly. This till 2:23 itself.
Okay, okay.
आता
हॅलो काय करतो जेवला का? अरे म्हणलं
Madam, you have joined us Pradnya K, right? Pradnya ma'am?
I thought you talked with me because my name is also Pranya.
Hello.
Yeah, ma'am, Pradnya K, you are right. You have
Yeah,
logged in.
yeah.
Yes, yes.
Okay, good afternoon.
Good afternoon, ma'am.
So students are still joining. Swati madam, you can add me as a host now.
Yes, ma'am, I'm doing it. Done?
Yes.
Okay, I'll start the recording as well.
Yeah. Thank you.
Yes, thank you, ma'am.
Yeah, yeah. Okay. So good afternoon, everyone. Can anyone quickly revise what we have done yesterday? Yes, anybody?
We discussed about networks.
Yes. Which types did we learn?
What is computer networks, ma'am? We did.
And which types of network we have learned?
Peer-to-peer applications.
Then what else? We did learn about LAN, WAN also, right? Okay, I'll share my screen. Yes, we did learn about PAN, LAN, WAN, MAN. Correct. Revise on this. I'll share my screen. You are going to tell me whether you are able to see the screen. Okay. Yes, can you see the presentation?
Yes, ma'am.
Yeah, very good.
Yes, ma'am.
Yeah. So yes, we were talking about yesterday. We did learn about this topology, LAN and ring and bus, right? I was telling you about ring and bus topology, right?
Yes, ma'am.
Yes. So we did complete about the LAN and PAN, personal area network. right? Then next what we are going to learn is metropolitan area network, that is MAN. MAN usually are usually large enough to cover a city. Best known example is a cable TV network. Originally, basically, cable TV, it was intended for television only, but it quickly became famous or used for computer networks once the cable companies determined that there was a money to be made, right? Why? Because these cable companies, they used to use a coaxial cables, right? There are different types of cables which can be used in the connectivity or in the hardware part of this network. So one of them is cable TV. Why it is called as cable TV? Because coaxial cables are used in these types of TVs or in this type of networks. So this covers MAN. MAN topology, that is how the arrangement of computers is done in MAN. The topology of a MAN usually results in a series of computers with a single entry point at the head end of the network. It is at the head end that the MAN would be connected to another network. So that is called as a MAN. Then WAN is nothing but a wide area network. WANs are much larger than MANs, covering the whole country or other geographical area. The user computers in the WAN are called as hosts. The host computers on the various LANs are connected via communication subnet, that is routers, which we use at our home also. So the subnet consists of routers and the transmission lines. You can see here a router is a specialized piece of switching hardware that is responsible for determining the direction of the data packets. We have seen what data packets are now, right? And how they travel. So they should be sent. Routers are responsible for directing the data down the transmission lines from one LAN to another. Then we have a structure of a wide area network. You can see here there are different LANs which are connected together by a subnet. Subnet is nothing but it's a collection of transmission lines, wires, plus routers. Whatever is shown as a circle are routers. Okay.
Okay.
Yeah. So that is, those are the
Ma'am?
routers. One, yes.
Router means?
Router is nothing but a device which, suppose if for example you want to have an internet at your home. Okay.
Okay.
So sitting at your home, you want to search something or get access to something. Where the request goes, suppose if for example you can see here, suppose you can see one machine which is host. Host is requesting for some information. So what it will happen, through this LAN, it will go to this router. Router kya karega? It will give send it to, suppose this host wants to have information from this machine. Okay, the machine from other LAN. So how it will go? It will go from this router, then router will give it to another router. This is like postal service. Then to another router, then to another router, then it will come and then it will go to a particular machine. Similarly, this machine will again send back the request, right?
Yes, ma'am.
So router is root. The router term comes from the word routing. So it will navigate the packets. Okay, it will find out the ways or routes to send the packets further. Those are called as routers. Okay. If you, I can show you how routers look. You must have seen routers. See, these all devices are called as routers. If you have internet at your home, or if you must have seen such devices in your college also, right?
Yes, like we have that Airtel, Tata Docomo and all.
Correct,
Yeah, ma'am.
correct. Got it?
Got it,
Absolutely.
ma'am.
Very good. So these are called as routers. So they are used to connect different machines. You can see here. You can see here. You can see router is connected to the switch. A switch is connected to different computers, and router is connected to internet service. So this internet service can be provided to all the machines through this router and switch. Okay. You can see this is your home network. You get a wireless router, you can connect to your any device
Yes.
which is there, and then you get the internet, right? Simple.
Yes, even the mobile phones.
Correct. There can be different routers present, right? You
Right.
can connect mobile phones also. Many things. Many things you can connect. You can see here. There are some routers. There are some devices in which router, switch, and firewall comes in the same device. Right? Nowadays, what we get is
Smart TVs.
correct. Smart TVs.
Yes.
Correct. That also we can connect. Are you getting? So router is very much important when we talk about WAN. Okay. Yeah. So that is called as a subnet. So subnets what actually do? Stored and forward and packet switched. The message is broken down into smaller packets to send, and each packet is sent out onto the network. As the packet arrives at the router, what does the router is going to do? It is stored there until the outgoing line is free, so that there won't be congestion, right? And it is then sent on its way. All the packets may take, it has to be may take same or different routes depending on if they are individually routed or not, right? So they are routed. Suppose, for example, you all are going somewhere with the bicycles. So if there are 10 people may take 10 different routes to reach to the destination, or some people may take one route, some people may take another route. So that is individual routing is done, right? It is possible to have a broadcast subnet. Like the best example is a satellite system, right? Where the data is broadcasted to everyone. With a satellite, no routing occurs at a satellite. It simply acts as a big dish TV. It is a WAN. Cable TV is a WAN, okay? To bounce the signals off, right? Okay. Before going to wireless network, we will quickly note down something about metropolitan area network. So just after LAN, just give the heading metropolitan area network, that is MAN. Done? Right, so that is metropolitan area network. Done? All of you?
Yes.
Acha, good. And just write down about WAN, few points about WAN, that is wide area network.
Excuse me, ma'am.
Yes.
How the host computers on various LANs are connected via communication subnet?
Can you repeat your question?
How the host computers on various LANs are connected via communication subnet?
How? The host are nothing but machines. You can see here, these are all machines, computers. Host is nothing but computer. Okay,
Okay.
so this is a bus topology. You can see this is a LAN. Okay, so it is as good as you are connecting 4 LANs together by routers, right? Just like we connect different cities by highways. We don't use
Okay.
highways to get inside the city.
Hmm.
But if you want to connect to different cities, we will connect through highways, right? And inside the city, we have our own roads, which is LAN.
Okay.
And when we go onto the highway, it becomes your subnet, that is WAN.
WAN.
Got it?
Got, ma'am.
Yes, very good. Yeah, just note down these points. Done? Right? Underline the words which I have underlined, like host, subnet, because that is what you're going to. Yeah, somebody was asking about the router. If you want to mention, here is one line about router. You can just put it in your notes. Okay.
Ma'am, metros is an example of man.
Perfect. Perfect. Very good. Finished writing?
Yes, ma'am.
Yes. So next is quickly note down this, draw this in your notebook to understand how WAN is structured. It is actually a collection of LANs.
मैडम
Yes.
प्लीज थोड़ा हिंदी में भी आप बताएंगे तो अच्छा होगा.
Yes. How many of you don't understand English? Yes. How many of you don't understand English? I can accordingly this thing. Do you have a facility to write answers in English? Sorry, answers in Hindi?
Yes, ma'am.
Oh, you must be then BA Hindi. Am I correct? Or MA Hindi, possibly. With the specialization in Hindi, right?
No, ma'am. Library, Masters of Information Library Science.
Acha, library. So your all curriculum is in Hindi? Neha?
Marathi, ma'am. Marathi, ma'am.
Acha, it is in Marathi. Then why you want me to speak in Hindi? I can speak in Marathi also. Why Hindi? I thought your medium of answer of English is Hindi, or you are doing specialization in Hindi. Anyway, we are talking about WAN. WAN म्हणजे हे सगळे जे networks आहेत. I'm just explaining in Marathi for a few set of people who want me to explain it in Marathi rather than in Hindi. Okay.
Yes, ma'am.
So,
हिंदी आप मराठी में भी बोलेंगे तो चलेगा.
yes, very good. So the thing is, हे सगळे जे LAN मधले machines आहेत, you can see की 4 LANs connect केले तिकडे, बरोबर? 4 LANs पैकी प्रत्येक LAN मध्ये वेगळे वेगळे machines आहेत. They are called as hosts, right? So ते host, suppose for example एका LAN मधल्या एका मशीनला दुसऱ्या LAN मधल्या दुसऱ्या एका मशीनला जर मेसेज पाठवायचा असेल, डेटा पाठवायचा असेल, तर LAN to LAN कनेक्शन नाही आता इथे, बरोबर? सो LAN to LAN कनेक्शन करायला काय वापरतात? राउटर्स काय करतील? रूट करेल पॅकेट्स. सो हे सगळे राउटर्स डिझाईन केलेले आहेत. राउटर्स डिझाईन करायला डिस्टन्स पण बॅरियर आहे, बरोबर? सो असं नाही करू शकत ना, एक राउटर इथे केला, एक राउटर अमेरिकेत हे केला. देर आर हॉप्स इन बिटवीन, राईट? सो ते सगळे हॉप्स यू कॅन सी सर्कल मध्ये जे जे केले ते सगळे राउटर्स आहेत. सो ते मशीनवरचा मेसेज तो राउटरकडे जाईल. राउटर वेगवेगळ्या राउटर्स कडनं त्या स्टार्टिंग पॉइंटला जाईल जिथे ते लॅन कनेक्टेड आहे आणि त्या लॅन मधल्या त्या मशीनला तो मेसेज बरोबर पाठवेल, राईट? दिस इज हाऊ WAN वर्क्स. गॉट इट?
Yes, ma'am.
Good. Okay, so have you drawn this? Have you drawn this diagram?
Yes, ma'am.
Very good. So now I would like to show you something about these networks only. Yes, transmission media.
Hi guys, welcome back to the Wiz block.
Can you all hear and see?
Yeah.
Yes, it's visible and
Very
audible.
good. Very good.
This is the Wiz Kid. Today we'll be looking at the transmission media or communication media. Now, what is a transmission media in a network? This is the means by which a signal moves from one network device or node to another. Now, the transmission media or communication media is divided into two categories. We have the guided and unguided. Guided media.
See, आता आपण काय बघतोय? What we are seeing is a transmission media. We have seen OSI model, we have seen networks, types of networks. So whenever you want to connect two machines, two devices, what is the medium that we are going to use? So there are two mediums, wired and wireless. Barabar? What is wired? Guided. What is wireless? Unguided, right? So let us learn guided first.
Refers to cables, and unguided refers to wireless. Now, the guided is divided into three categories. We have the twisted pair, we have coaxial, and the third category is fiber. Twisted pair is further broken down into shielded twisted pair or STP and unshielded twisted pair or UTP. Let me show you an example of the unshielded twisted pair. This is an example of the unshielded twisted pair. Now with the unshielded twisted pair, there are two copper wires. These are two copper wires, and they're surrounded or insulated by a thin layer of plastic. Twisting prevents interference from the wires. They're normally used with the RJ45 connector. Show you an example.
Very important. You must have seen this type of cables. Can you tell me where have you seen twisted pair?
Yes.
कुठे बघितले twisted pair cable?
Very simple example is the rounded adapters that we use.
Correct. Rounded adapters that you use. What about your telephone cable?
Yes.
What about the cable that carry electricity?
Yes.
Right.
Mobile charger, man.
Very
Even
good. Mobile charger.
the lightings we use in any festivals.
Correct. That is twisted pair. Very good. Ironing. The iron.
Yes,
So
the
that cable
iron.
is also, yes, that cable is also shielded. Shielded is usko cover hota hai. Unshielded is loose cables.
Yes, even
Right?
the vacuum cleaners.
Correct. Vacuum cleaners. Everywhere we use these cables, right? So they are basically transmission media. They are used to transmit. They're called as twisted pair.
Example of the RJ45. We use it a lot when we're setting up our network. This is the RJ45.
This connector also you must have seen. Can you tell me where did you see?
Telephones, the landlines.
Correct. In telephones, on your laptop also there this connector must be there. In on your computer
भी होता है ना?
Hmm?
कंप्यूटर को भी होता है नहीं?
Yes, कंप्यूटर की को भी होता है. हम लोग अटैच करते हैं इससे ये कनेक्टर से. This is called as connector. It is there in the router also. It is there in the computer
Yes, in
also.
the routers, right.
Yes. So this is everywhere. This is called as registered jack. That is why it is called as RJ45. All these things you must have observed. I'm just trying to tell you all these aspects from the networking point of view, right? So याची जी केबल असते ती पण twisted pair असते, right? This cable which is used here is also twisted pair.
45. So these wires would connect. Now the shielded twisted pair is kind of similar to the unshielded twisted pair, but it has a separate insulation material between each pair. As you can see right here, each pair of wire has a aluminum foil insulator. This further prevents crosstalk or interference. Crosstalk is when the wires, two wires, interfere with each other. The shielded twisted pair is normally more expensive than the unshielded twisted pair. Now, the shielded twisted pair, or the unshielded twisted pair rather, it's broken down into 5 categories. Now, the first is category 1. The category 1 cables are used in telephone wires. It's used for voice. Category 2 or Cat 2, they're used to transmit data up to 4 megabytes per second. So data at 4 megabytes per second. Cat 3 is used to transmit data at 10 megabits per
No need to remember all these things. This is for your information. Cat is category. Category 1, category 2, category 3, like this. Okay. So category 1 was older, like telephone wires, then data at 4 Mbps. Mbps is nothing but megabits per second. Okay.
per second, or Ethernet at 10 megabits per second. Cat4, this is token ring, use transmit data up to 20 megabits per second. And Cat5 or fast Ethernet, which is what we really use in our homes to get the internet, it transmits data at 100 megabits per second. Okay, as I said before, the shielded twisted pair is usually more expensive than the unshielded twisted pair. Because the shielded twisted pair is shielded, allows the cable to run longer lengths than the unshielded twisted pair. Next sided media is the coax. Right. Let me show you an example of the coax. I think we're all familiar with the coaxial cable. This is how the coax looks. The coax cable has a central conductor. This is here, normally copper. It's surrounded by an insulating material. This is normally called a dielectric material, and then it's normally dielectric is surrounded by an copper mesh, and then everything is encased in an outside insulation material. Coax cable, it allows runs of distance of up to 500 meters and can support up to 100 nodes on a network. It's very resistant to interface, is more expensive than the twisted pair cables. Fiber or optical fiber, this uses light pulses rather than electrical signals to transmit data. Normally made of glass or plastic, has a small silicone core. So it has a small silicone core. The core is normally made of silicone and encased in some light absorbent material, plastic called cladding. So this is the cladding. It has further insulated material. So as you would probably imagine, this type of media is hard to tap into, penetrate, because once you break the core and the signal is lost, it's much more secure than the two other categories of transmission media. There are 5 forms of optical fiber. First one is the multi-mode mode. With this form of optical fiber, the light.
Optical fiber, coaxial cable. Coaxial cable we all know because we have studied it in MAN, right? We have studied it in MAN because MAN itself, the network came into the cable industry. We have brought the this particular coaxial cable, right? Coaxial cable also you can see everywhere. Computer cables, projector cables, refrigerator cables, microwave cables, all these cables, they are coaxial, right? So those are called as coaxial cables. So copper wire will be there, insulation will be there, outside insulation will be. They are more strengthened and they are more bulky also, right? You can see that, and then we can see the optical fiber is the lightest one, right? Nowadays you can see the geo network comes in the optical fiber format, right? Now, before we go further, just quickly write down this classification. You can just write down this classification.
Excuse me, ma'am, I have a question.
Yes.
The cable that you showed just now, the center copper part and the insulating part, is it the cord that we use behind the CPU? There's a circular port we insert.
It's the same port which we use.
Okay, and even for the this thing for modem to connect it to the telephone, the older ones.
Yes, the older ones, the ones which are very bulky.
Yes.
You remember, they are heavy cables. Those all cables. तुम्हारा कॉलेज का प्रोजेक्टर को जो लगता है केबल, वो वाला केबल.
Okay.
If you see the generators, electric generators wala cables. If you see the cable of refrigerator or microwave, high intensity, those are all coaxial.
Okay, so simple is the thick ones.
Correct. The thick ones, the round ones are coaxial.
Okay, thank you.
Yeah, and they are guided because wired. No, we are talking about wired.
Yes. Okay.
So just quickly write down this classification. Unguided के लिए थोड़ा जगह छोड़ दो because we need to learn unguided. Let me know once you finish. Done. Very good.
Excited media is the coax, right? Let me show you an example of the coax. I think we're all familiar with the coaxial.
See, when we say that cable TV, हम लोग cable TV बोलते हैं ना, that cable TV का cable word is come from coaxial cable. That is वो coaxial cable use करते हैं, इसलिए उसको बोलते हैं cable TV. Okay.
Cable. This is how the coax look. The coax cable has a central conductor. This is here, normally copper. It's surrounded by an insulating material. This is normally called a dielectric material, and then it's normally dielectric is surrounded by an copper mesh, and then everything is encased in an outside insulation material. Coax cable, it allow runs of distance of up to 500 meters and can support up to 100 nodes on a network. It's very resistant to interface. Is more expensive than the twisted pair cables. Fiber or optical fiber, this uses light pulses rather than electrical signals to transmit data. Normally made of glass or plastic, has a small silicone core. So it has a small silicone core. The core is normally made of silicone and encased in some light absorbent material, plastic called cladding. So this is the cladding.
Though there is an insulating material or there is a cladding is there, basically optical fibers, they are very much light in weight. They can run under the water also. They can run under sea also. If you can see new networks having higher bandwidth, geo network, right? Geo fiber is coming, right? So that is nothing but optical. They are using optical fiber everywhere. Reliance is using optical fiber to provide networks to their customers. Okay, internet service to their customers. So that geo fiber is nothing but that fiber word comes from optical fiber. Okay.
As further insulated material. So as you would probably imagine, this type of media is hard to tap into, penetrate, because once you break the core and the signal is lost. It's much more secure than the two other categories of transmission media. There are 5 forms of optical fiber. First one is the multi-mode mode. With this form of optical fiber, the light comes in at a variety of angles, and the bandwidth is less than 200 megahertz. Let's use B to represent bandwidth. The bandwidth is less than 200 megahertz. The second form is known as a multi-mode graded index. With this mode, the fiber bends signals as they approach the cladding instead of reflecting them. This supports a bandwidth between the range 100 megahertz to 3 gigahertz per kilometer. It would be at 100 megahertz, 3 gigahertz per kilometer. Our third mode is called the single mode. Single mode normally supports the highest bandwidth because the diameter, as in the central core right here, is reduced, only allowing one light signal to pass. It supports bandwidth up to 50 gigahertz per kilometer. Fourth mode is breakout cable. Breakout cable, this has several fiber. Each has its own cladding and a jacket surrounded by a larger jacket. What this means, let's say this is a fiber. Oh, I don't have an example. Okay, let's say this is our fiber cable, right? Each fiber is surrounded by its own cladding.
See, megahertz, hertz is nothing but a frequency. You need not be going into detailing of these. These are only the types of optical fiber. Okay, so it is as good as you get it in variety. Okay, high, low end से high end तक उसके हिसाब से उसका price होगा, and you get the better quality and better speed, right? We only tell our Airtel से नई speed मिल रहा है, नहीं तो Vodafone का network नहीं चल रहा है, Jio का अच्छा है, इसका ये है, right? How do we decide all these things is based on the speed and the quality, right? So because of these,
will be surrounded by this little section right here. Each fiber cable will be surrounded by this siding as well as its own jacket. And then we have, let's say we have 12 fibers in the cable, and each individual fiber will have its own jacket, and all 12 will be surrounded by a larger jacket. That is what the breakout cable, or other type, is called the distribution cable. Now the distribution cable is really a breakout cable in a larger jacket. That is a distribution cable in a larger jacket. Final is called the loose cable. Loose cable. Now the loose cable has 1 to 12 fibers that are floating inside a loose tube filled with a gel. That's what the loose cable does. Next, go on to unguided media. Well, let's try and clear up this workspace. Unguided media. Okay, so the unguided media uses electromagnetic waves, and the signals are broadcasted through free space. So we use electromagnetic waves, and they're transmitted through free space. Now the wireless.
Next is unguided. That's electromagnetic waves. Which are unguided media? Those which are in the form of waves, right? So that is called as wireless or unguided transmission media. Okay, unguided is nothing but wireless. Okay, so there are different types. Wireless. We all use different. We all use different ways in which we can use the unguided media, right? We can use it in Android PCs. We can use the transmission in terms without wires for many other things. One of them which we have used is satellite also, right? Which gets the signals. Can anybody tell me what are electromagnetic waves?
The waves that are in X-ray machine.
The waves that are in X-ray machine. Okay, very good.
Simple
What about
as the
infrared?
ultra.
What about infrared, which is there in the remote controls?
Yes.
Right. Radio frequency, which is used in radio mirchi, microwaves, satellites, Wi-Fi, Bluetooth, right? Cellular radio,
AirPods.
AirPods, right? Which basically like a broadcast radio, which distributes the radio signals through air over a long distances, such as between cities, regions, and countries, right?
Yes.
So that is called as wireless. So no physical medium is required for wireless communication. It can carry the signals through air, water, or vacuum, right?
Ma'am, X-rays, for example. X-rays.
Even you mentioned yesterday about the wireless keyboard and mouse as well, no?
Yes, I have told you about wireless keyboard and mouse also, right? That is wireless. No physical medium is required. It can, so there it can carry the signals through air. Bluetooth is an example of wireless keyboard and wireless mouse, wherein you can connect them with the dongle, and then, but they should be at the nearer distance. They should be nearby to get it connected. But when I'm talking about wireless transmission media like infrared or many other, it can travel large distances, but they're also less secure. That can be trapped very easily, right?
Right.
One of the example is infrared. Infrared is used for short range communication like television remotes, mobile phones, personal computers, right? Like mouse and keyboards. So there we can use infrared. You can see the right when you put on the mouse, wireless mouse, you get that red light also, right? So basically it has a science, like infrared is a part of a spectrum that is not visible to human eye, but it is used in the night vision cameras as a thermal properties, right? So it can basically they cannot penetrate any obstacles, and they can use it for they can be used for short range communication or transmission, right? Then we use radio waves. Radio waves, you can use it in FM radios, cordless phones, right? You must be knowing cordless phones. Also, some private and government organizations reserve certain radio frequencies for direct communication, like raw agencies, forensic agencies, they use them, right? Radio waves, there is a disadvantage. When we talk about radio waves, they are not effective in the bad weather conditions, and they are less secure as they can travel the large distances, right?
The best example is Tata Sky.
Best example is Tata Sky. अब बारिश आ गई खत्म,
Yes.
right? Yes. Many times you have to restart that set-top box also. Next is microwave. Microwave is nothing but a line of sight transmission. Like both the antenna sending and receiving should be properly aligned. Then only you can use those microwave, right? Microwaves can be used in mobile phones, communication, and television distribution. Right? That is where you can use microwaves. This is a little expensive type of a transmission media. And microwave
Even
also,
the Xbox, right? The
yes,
kids,
yes,
they
even
play those remote, their
yes,
wireless.
yes,
Yes.
correct. In that those Xbox variations also you use it, right? And why? Because there is no need to dig wires and spread the wires. Wireless, you can easily play that, right? So, but again, same thing. Microwaves are also not very effective in the bad weather conditions, and plus their installation maintenance is very much expensive.
Yeah.
Yes. So these are all different types of wireless communication. Okay. Now you can, yeah. Yes. Now we can see about the wireless
media. Magnetic waves, and they are transmitted through free space. Now, the wireless signals travel by either ground, sky, or line of sight. Ground waves or radio waves that travel sky. Ground waves, as I said, ground waves travel close to the ground. Sky waves travel at high frequency waves in the ionosphere. There are radio waves between the range 3 kilohertz to 1 gigahertz to 1 gigahertz. Next, we have the line of sight. The line of sight are very high frequency signals that travel in a straight line. They're normal microwave, 1 gigahertz to 300 gigahertz. And that's really communication media / transmission media in a nutshell. Now, thanks for watching.
Yeah.
And media / transmission.
Very quickly, just note down these three. We are writing classification. No, I told you unguided wireless ka chhod do. Usme you can write these three. Electromagnetics can be at the ground and sky and line of sight. That is radio waves and microwaves. When it is in the sky, it is radio waves. Line of sight, microwaves. Ground, electromagnetic waves. Just note them down.
Ma'am, Vivek here. Can you tell me an example of ground wave use?
Electromagnetic waves which are used at the ground, right? You want to say? Can you guess, Vivek?
Ground waves, no, ma'am.
Ma'am, the waves that goes in the sea.
Are those ethered wires waves?
No, we are not using wires. No, this is wireless.
Oh, okay.
So
I'm confused.
system
See,
for marine
basically,
navigation.
yes. Who is telling something? Yeah, tell me.
Yes, ma'am. Sonar system.
Sonar system, okay. See, basically, when I'm talking about electromagnetic waves differ from the mechanical waves, right? Then they don't require medium to propagate. Electromagnetics can travel not only in air or solid materials, but also in the vacuum. So when I'm talking ground, it doesn't mean that ground matlab ground pe. It is nothing but they can travel in air also, solid material through the solid materials also, and vacuum or space also, right? That is where satellite comes into picture. Electromagnetic waves are used everywhere, right? If you remember, you must have learned it in physics about relay waves. I don't think you will remember, but that is what is the ground level waves, right? Even some kind of a radio propagation can also be used in the ground electromagnetic waves. That is generally called as surface waves, right? So it depends on the frequencies, whether it is ground wave propagation or whether it is mid-level propagation or it is at the line of sight. Microwaves are generally at the line of sight, right? But when it is electromagnetic waves or electromagnetic radiation, it can happen in space also. It can happen through space also because those waves can run through vacuum also, right? Those waves can run through the solid materials also, and they can run in the air also, right? So basically, when I'm talking about electromagnetic waves on the ground, or generally they are called as ground waves, they are basically used for transmission between the surface of the earth and the ionosphere, right? So that is, it will be made up of different low frequencies of the electromagnetic spectrum, right? So that is where it is called as a ground. Are you getting, Vivek?
Yes, ma'am. Got it. Thank you.
Yeah, very good. Yeah, so please note this. These are important parts of navigation, sorry, not navigation, parts of communication media and transmission media. Okay. Done?
Done, ma'am.
Very good.
Media in a nutshell. Now, thanks for watching.
Right. So these are different types of. Yes, Praveen has said something for cancer therapy radiations are used, right, Saurav? Very good. I just would like to see some messages which I have missed out.
Excuse
Okay,
me.
range of, what is the range of the subnet? The range of the subnet is nothing but the area it can be covered by the subnet. That is the range, right? Yes, radiations can be used for cancer therapy. Correct. These waves propagate over the Earth's surface in low and medium frequencies. Correct. That is what I was telling you about the ground waves. Right. Very good, Praveen. Yes.
Can
Any queries so
earthquake
far?
be an example?
Earthquake can be
an example of the Rayleigh waves that you mentioned?
Yeah. Relay waves में अगर disturbance हो गया, it results into the earthquake. Right. So when you are using those powerful waves for the transmission of data, they can be used as a communication media. That's it. Right. Any queries till now? Yes, you have any queries?
No, ma'am.
Okay. Then I think we will take a break for 5 minutes and then again I will be continuing. Just have a water or a bio break. I'll also have water and I'll be back in 5 minutes. Okay. And then we'll continue with the next topic, that is crimes. We have to start with cyber security.
Hello, ma'am.
Right?
Hello, ma'am.
Yes, Praveen.
मॅम when we talk about ground wave म्हणजे आपण असं म्हणतो की जेव्हा आपण ट्रान्समीटर आणि रिसिव्हर मध्ये जेव्हा आपण सरफेस बद्दल बोलतो ना आपण अर्थच्या,
बरोबर,
तर त्यामध्ये एखाद्या वेळेस जर सरफेस कुठं टिल्टेड असेल किंवा काय उंच सरफेस असेल तर त्याच्यामध्ये डिफिकल्टी येऊ शकते का?
नाही येऊ शकत, कारण सॉलिड मटेरियल्स मधनं पण इलेक्ट्रोमॅग्नेटिक वेव्ह जातात ना.
अच्छा अच्छा.
कळलं का? हे बघ, हा प्रॉब्लेम रिमोट
लो
मध्ये
फ्रिक्वेन्सी. ओके. हा.
रिमोट, आपला रिमोट कंट्रोल मध्ये तू जर उभा राहिलास मध्ये टीव्ही आणि रिमोट कंट्रोलच्या, तर कधी कधी चॅनल लागत नाहीत बघ. बरोबर
बरोबर मॅम.
हा, तर तो डिस्टर्बन्स तो असतो, पण दॅट इज नॉट देअर इन केस ऑफ ऍट द सरफेस. कारण या वेव्ह व्हॅक्यूम मधनं पण जाऊ शकतात ना आणि सॉलिड मटेरियल्स मधनं पण जाऊ शकतात.
Ma'am.
Okay.
Yes.
What called that disturbance then?
काय झालं प्रज्ञा? काय तुझी क्वेरी? मला कळली नाही, परत सांग.
म्हणजे तुम्ही जे उदाहरण दिलं ना की टीव्ही आणि रिमोटच्या मध्ये जर उभा राहिलं तर त्याचं नेटवर्क जात नाही
कारण सिग्नल्स नाही मिळत ना, त्याला सिग्नल्स नाही मिळत. रिमोट कंट्रोल टू टेलिव्हिजन हे डिस्टन्स छोटं असलं तरी पण त्याला सिग्नल्स मिळत नाहीत, कारण मध्ये कुठलंही ऑब्जेक्ट ठेवलं तर टेलिव्हिजनच्या.
हा, तर त्याला काय म्हणतात मग?
त्याला काही नाही म्हणत, त्याला इंटरफरन्स म्हणतात. डिस्टर्बन्स, एनी डिस्टर्बन्स.
ओके.
इंटरफरन्स म्हणतात. सो दिस इज ऑल जेनेरिक इन्फॉर्मेशन, यू नीड नॉट मग अप. हे सगळं आपण इकडे तिकडे बघत असतो आपल्या आजूबाजूला. नेटवर्क्स आपण यूज करतो, त्याच्यामध्ये आलेले वेव्स आपण यूज करतो, राईट? वायर्ड अँड वायरलेस सगळं यूज करतो आपण. राईट? Okay, let's have a break. I'll also have water.
जेवढा वेग मला सुरुवातीला भाव मिळाला ना, तेवढाच त्याचे 1000 पटीने कमवला है ना. त्याला कारणीभूत तो स्वतः मला तरी आपल्याला पण नेट मागितलं गे नाही. नवरा मागत नाही, नवऱ्याचा तर पूर्ण अधिकार.
Yes, are all back from the break? Shall we continue? Yes, all are back. Good. Yes. So let us continue. You were talking about the wireless networks. Yes, before that, I would like to show you something on the devices. Different. We were talking about routers and hubs, no? So let us quickly understand what are different devices, network devices. Okay.
Hi guys, David Robinson here, and thanks for joining me for this module, Types of Network Devices. In this video, we're going to cover some of the more common types of physical networking devices and explain to you guys what each device is and give a basic overview of its core functionality. Now, we won't discuss the intricate details about how each device works because that's going to take quite a bit of time for each device. But at the end of this video, I want you guys to be able to identify, at least visually, the different types of devices and possibly.
See, visually, at least you should be able to identify these devices which are used in networking, and only for that reason we are listening this. Okay, we are not going into technical details of it.
Be able to explain, their core function and maybe some of their specifications. Now, I'm not going to look at a lot of devices, okay? I just want to cover in this module the core devices that's required to give you a base network connectivity. So as you start to learn a bit more, some of the other devices will be introduced and we'll cover them as well. So let's start off and take a look at some types of cables, okay? The first cable that I want to touch on very briefly is coaxial cable, or actually coax for short. Now, something that you need to be aware with coax is that it's a very old cable standard and it's generally no longer actively used in computer networks, okay? The general speed or the maximum speed of coax cable is 10 megabits per second, which in today's standard is actually very slow. And you may be aware a lot of internet connections are already faster than that, and wireless connections as well. Your 3G, your 4G services that you get through a phone provider are faster than that. So it is a very old standard, but this at least allows you to see what coaxial cable looks like. We can see there we've got a cable on the left, you can see the ends, and on the right there is the cable basically with the plastic sleeving taken off. So you can at least identify this cable. If you do see it out and about, just know that you should chuck it in the bin. Okay, so the next cable standard that I want to look at is called twisted pair. Twisted pair is actually the most common cable standard, and you basically see this everywhere you go. Your home network may have this cable. Okay, these cables are actually made up of copper wires, and twisted pair gets its name as each pair of copper wires is twisted together and that helps to prevent crosstalk and interference with other nearby wires. And you can actually see that in this bottom right-hand image. Let me see if I can get a laser pointer. There we go. So the bottom right-hand image, you can see those pairs that are actually twisted together. Okay. Now, as I said,
this we have already seen, these cables, okay?
There's a total of 8 wires twisted together to form 4 pairs, okay? And there are 2 types of twisted pair cables. There is shielded twisted pair, or STP, and unshielded twisted pair. Unshielded twisted pair, or UTP, is definitely the most common, and basically UTP is that each individual wire is covered in its own plastic sleeve, okay, and then all the wires are then covered in an outer plastic sleeve, and that's once again, that is exactly what you can see down here. Shielded twisted pair is basically includes a metal shielding around the twisted pairs, and that helps to prevent electromagnetic interference. So if you were to imagine this image here in the bottom right with all 4 of these wires wrapped around some sort of a foil looking metal, okay, before before the plastic sleeve is put on the outside, that's what shielded pair is. And each of these wires can also have that metal shielding on them as well. But yeah, it is not as common, it can be a bit more expensive, and you won't use them in the home or the small network at all. Okay, UTP comes in several categories. Okay, the common ones that you will probably hear, or category 3 you may not hear, but there's category 3, category 5.
I told you about Cat 1, Cat 2, Cat 3. Cat 1 is telephone line, so that all those categories, right?
Yes,
category 5 and category 6. Now, each of these categories comes with their own set of specifications, but just for the sake of simplicity, just be aware that each jump in category is a jump in the maximum transfer rate that that cable can support. So Cat 3 is, like I said, it's rather old. You may not hear it as much anymore, but it has a maximum transfer rate of 10 megabits per second. Once again, that is fairly old, just like the coax cable. And category 5 is fairly common, and that has a standard of 100 megabits per second. Okay, category 5E has a maximum rate of 1 gigabit per second, and Cat 5 and Cat 5E are basically the cables that you're most likely to encounter in the home environment or the small business environment. Cat 6 can really have a maximum at 1 gigabit per second or up to 10 gigabits per second. Okay, now, and the Cat 6 really is what you will see in larger environments that do need that high speed network connectivity between servers and high performance devices. The adoption of Cat 6 has picked up. So a few years ago, well, 2013 now, but a few years before that, Cat 6 was fairly slow to be picked up and adopted by the industry, but today the price has come down a lot, and adoption has picked up, and you'll see it being used a lot more. Okay, all these cable standards are terminated at the end with a plug that's called an RJ45 plug, and that's the plug that we can see up here in that top left image.
That is the RJ45 plug which we were talking about, which is present in telephones, modems, routers, right? Many devices. Correct.
Excuse me, ma'am.
Yes.
Some students have their stream from arts.
Okay.
So I'm also from art stream. I'm some concepts are not clear into me.
Yeah. So tell me what is not your understanding.
Okay.
Tell me what is not understanding. What is your query? Tell me. काय नाही समजलं?
मॅम मी थोडं वेळ सांगितलं चालेल का?
का? समजलं नाहीये ना, मग सांग ना काय नाही समजलं.
तेच समजलं नाही मला हे केबल ट्विस्टेड पेअरचं.
अरे ट्विस्टेड पेअर केबल तुझ्या घरात कुठे आहे मला सांग बरं. बघितलीये घरात? तुला जी दिसतेय समोर चित्र ते कुठे बघितलंय सांग.
कॉम्प्युटरला.
बरोबर. अजून? मोबाईलच्या
अजून
चार्जरला कुठली असते केबल बघितलंय?
हो, मोबाईल चार्जरला पण असते केबल.
आणि
आणि वायर ते जे असतं ते आपल्या घरात शेगडी असते ते पण
आकाश
यूज.
कंदील लावलायस का कधी? आकाश कंदील लावलायस का कधी?
हो.
त्याचा स्विचची वायर पण अशीच असते की.
हो.
बरोबर ना? फक्त कव्हर असतं वरती.
ओके.
आणि आकाश कंदील छोटे छोटे लावतेस ते तर ओपनच असतात, अनशिल्ड असतात. बरोबर?
येस
शिल्ड
मॅम.
म्हणजे कव्हर. ज्याला शिल्ड असतं ते कव्हर, ज्याला अनशिल्ड असतं ते म्हणजे ओपन असतात त्या. ज्या तुला दिसताय तिथे पिक्चर मध्ये.
येस मॅम.
मग काय ह्याच्यात नाही कळलं? दिस इज
आता
सो
कळलं.
सिम्पल. दे आर ओनली यूज फॉर ट्रान्समिशन. कळलं काय? ते इलेक्ट्रिसिटी ट्रान्सफर होते, नंतर डेटा ट्रान्सफर होतो, नाहीतर हीट ट्रान्सफर होते. बरोबर?
ओके.
सिग्नल्स ट्रान्सफर होतात. त्यापैकी काहीतरी एक ट्रान्सफर होतं म्हणून त्याला ट्रान्समिशन मीडिया म्हणतात. लक्षात आलं?
येस मॅम.
गुड.
Excuse me, ma'am, regarding the Cat6 that they mentioned, is the basic example, are these the different streams in the MNC companies that they use for their network connection, like servers and all?
Yes. To connect with their servers and to connect with their
During the con calls they have.
correct. So
Okay.
that is where they use. हा RJ कनेक्टर तर खूप कॉमन आहे. तो खूप ठिकाणी यूज केला जातो. खूप ठिकाणी तुम्ही बघितला पण असेल कम्प्युटरमध्ये. आता परत बघा तुमच्या कम्प्युटरला, लॅपटॉपला की हा आहे की नाही. राईट? बेसिकली जे डेस्कटॉप कम्प्युटर्स आहेत त्या प्रत्येकाला हा स्लॉट असतोच. म्हणजे ही पिन इन्सर्ट करायचा स्लॉट असतोच.
Okay. Now that plug, you might look at it and think it looks like it's a phone cable. Well, it's not. It's actually slightly larger. Okay, a phone cable is generally called an RJ11 or.
फोन ज्यांच्याकडे टेलिफोन आहे त्यांना तर हा कनेक्टर माहितीच असला पाहिजे. कारण जी वायर तुमच्या घरात जाते ती तिथे त्या ह्या कनेक्टरने टेलिफोनला अटॅच होते.
Yes.
Possibly an RJ14 or an RJ25. But RJ11 is really the one that you probably see at home. And this one is an RJ45. It is slightly larger with more cable pairs inside. So a standard cable may have, standard RJ11 will probably have 4 wires inside. Okay. The next cable that I want to mention is fiber optics. Now, you may never have seen this before, but I want to touch on it very quickly. And fiber is
या वायर पण तुम्ही बघितल्या असतील. या ऑप्टिकल फायबर आहेत. थिन असतात आणि लाईट वेट असतात. आणि ओपन केल्यानंतर तुम्हाला कळतं की ते सगळे फायबर्स आहेत. राईट? से फायबर वाला तुम्ही हे पण बघितलं असेल की ऍट द टिप ते लाईटन होतं. असे काही पण शो पीसेस असतात की जे ऑप्टिकल फायबर्सने बनवलेले असतात आणि ऍट द टिप ते लाइटनिंग चालू होतं. बाकी तुम्हाला त्या वायर्सच दिसतात पण टिपला ते बरोबर लाईट होतात. ऑप्टिकल फायबर्स.
Slightly more complex type of cable in the specifications and how it's and how it works. Well, it's a lot more complex in how it works. Okay, and it's used for larger networks and high-speed backbone connectivity. Fiber is basically used to link buildings together and countries together. Lots and lots of fiber optics are run, through the ground or across the ocean floors, and they're basically the speed of light. Okay, the cable carries pulses of light along a glass cylinder. Okay, the cylinders themselves are very thin. Okay, and be aware that if you ever handle this cable, that it's very fragile. So you should take a lot of care. Definitely more fragile than copper, because if you bend it too far, it will actually break the glass inside, and when that happens, the cable is useless. Okay, they are expensive, but they are coming down in price, and they are ultimately used for high transmission rates, and they don't suffer from the same noise and crosstalk issues that the copper twisted pair cables suffer from. Now, I don't want to talk about fiber anymore here because it is something that you'll find in much more corporate enterprise type environments, and typically you're not going to experience this cable in a home or a small office environment, but I just wanted to include it so that you're aware, if you ever do see this cable, that you do know what it actually is when you see it. Okay, the next device I wanted to show you guys were network interface cards, or NICs for short. Now, these devices are cards that are installed inside of a PC. So on the left, we've got pretty much a fairly common card which many PCs will have. Okay, and it has a single port on the back, and it takes a twisted pair Ethernet cable with an RJ45 plug. In the middle, we've got a Wi-Fi card, and you can see it's pretty easy to identify because of the antenna that's on the back. And on the far right, we've got a multi-port NIC. Okay, so a NIC can have.
You must not have seen this कारण हे कॉम्प्युटरच्या आतमध्ये असतं, बरोबर? सो दिस इज नेटवर्क इंटरफेस कार्ड. एखादा मशीन दुसऱ्या मशीनला जर कनेक्ट व्हायचं असेल तर what is used is network interface card. Okay, just like तुम्हाला तुमच्या मोबाईल मध्ये सिम कार्ड टाकावं लागतं, बरोबर? सिम कार्ड टाकल्यानंतर what you can do, connect to the service, जी तुमची इंटरनेट कॉलिंग सर्व्हिस असते ती, बरोबर? तसंच कॉम्प्युटर मध्ये it is a network interface card, right?
You know, more than one ports in it, and as we can see here on the right, we've got a NIC with 4 ports. It can take 4 Ethernet twisted pair cables. Okay, and usually those cards are found in servers that require, you know, many network connections for performance reasons, or perhaps this server is connected to a couple of different networks or services. Okay, all computers on the network must have a NIC of some kind. Now, they may not be expansion cards like this. Okay, a lot of new devices and new computers have all of this hardware built onto the main board, or you know, your phone doesn't have this big card in it with an antenna sticking out. It's a very small device that's built on. Okay, and basically what these cards do is they provide the interface between the rest of your PC and the physical cables that will connect to all the other devices on your network. Now I want to move on and take a look at network switches. Okay, network switches are critical.
Network switches also, you must have seen it in your lab. We don't get them at home. They are used to connect larger networks. Okay. So this you can see in companies, colleges, institutions, universities.
Cool. In allowing basically all of your devices to connect to each other. If you can imagine, if we think about it, if we've only got a network card in our computer, network interface card in our computer, and every other computer has a network interface card, that would mean if I wanted to connect to each computer, I would have to have a card for every single computer or device that I want to connect to. You can imagine if you're connecting to 10, 20, 100, 1,000 devices, you can't have that many cards in a computer. So what we use are network switches. Okay, our PCs and other devices will connect to the switch, and then that will enable that interconnection between all of our devices on the network to be able to talk to each other. It's basically a physical link between everything. Okay, now I should note that you can connect 2 NICs directly together rather than going through a switch, but there are a couple of minor considerations in doing so. But just be aware it can be done, and you can always hit me up on the forums or something and ask how to do that if that is a concern or a question that you've got. Now, switches can come in all sizes, as you can see from the diagrams here. On the left, we've got a small 8-port switch, which is basically what you. In the middle, we've got a 48-port switch, and that's what you're going to start to encounter in the business environment. Okay, and on the right here, I've got a really big switch. Okay, and that's a switch. I just wanted to include that switch in this diagram to show you that switches can come in all different sizes, and that's a good representation of everything being plugged in and running. Okay, now that switch could be fairly old. I'm not sure if
Who is speaking?
many tens or hundreds of network connections going into them. And the next item I wanted to talk about is basically network routers. Okay.
Acha, please be yourself on mute. Otherwise, I have to remove. Okay. Right. So routers nowadays, what we get is better routers than these routers. Okay.
Now, a router is a device that is used to connect two or more individual networks together to connect to the network, but it's to allow networks as a whole to talk to each other. Now, it's a bit hard to understand, but we're going to look at a network sample in the next slide. But I've included some photos here of some routers and what they generally look like. So this over here is a router. It's a home grade router, and you'll probably look at that going, that's not a router, that's a modem. And you're right, and you're not. So the route into it, which acts as the dialer for your ADSL or connections or cable or whatever connection it is that you've got. Okay, in the middle we can start to see these are sort of corporate grade routers. They're a couple $1,000s a pop, and then we can come over here and see some of the the very big rack size types of routing devices that are used in large communication environments and those sorts of things. So let's just jump over and have a look at this this slide that I've briefly mentioned. So the first thing that you should know in this slide is that we do have two individual networks. Okay, we've got a network A on the left and network B on the right. Now, each of these networks contains a collection of devices that are connected to their local network. Now, be aware when I use the term their local network.
See, this is how networks are made. This is how networks are designed. We were designing the network for healthcare, right? So printers are there, switches are there, servers are there, computers are there, right? You can see your internet also. You can connect to internet network through the router, right? So same is the case. We have Wi-Fi router at home who connects with the internet network. Simple networking design is this.
I'm not actually talking about the physical location. Okay, both these networks could be in the same building or they could even be in the same room. And for the purpose of this this particular diagram, I want you to assume that these networks are in the same office, the same room. Okay. Now, there's a lot of technical terminology to define this and what breaks these networks up, but I'm specifically avoiding using those complex words because I don't want to drop these words without giving the in-depth explanation. Okay, and you'll get those explanations when we cover the dedicated videos on IP addressing, subnetting, and routing. So over here on network A, we've got a connection to the internet, which you can see there. Okay, and that internet connection comes down into a router or a modem. And all these...
See, this is how two different networks can be connected. You can see network A and network B. And there is in between one router which you can see. This is nothing but different networks connected together using a router and transmission lines. That means this is a communication subnet. So it is a wide area network. The moment you put router in between and connected to networks, वो ज़्यादा wide हो गया. So this is a wide area network. Right? Otherwise, individual network A and individual network B are local area networks, LANs.
Well, basically, let's break it down. In the local network, very simple, and each network is very simple in its own right. Okay, they've each got a bunch of devices, and I've replicated them for the most part, just for the sake of simplicity. So we can see each network, we've got a bunch of servers here. Obviously, at home, you're probably not going to have them. We've got a bunch of computers and desktop users, and maybe some printers in there in the network. And each network has the same sort of thing, with the exception network A has a connection out here to the internet. Okay, so we can see here the computers, they're going to obviously have a NIC inside of them. Okay, we can see these devices are being connected by physical cables up to our switch. Okay, and the switch takes all of these connections in and allows these devices to talk to each other. So the computers can talk to the servers can talk to the printers, you know, whatever way you want. Now, the problem comes if these computers want to talk over to these servers. Okay, we've got no actual way to do that because we're in completely different networks. So what we do is we introduce a router. Now what happens when this is properly configured is these computers want to talk to the server. Well, they talk to the router first. The router has a record of all the devices in either network. When it receives that request from these computers, it goes, oh, I know where to send that. And it sends it straight away to these servers. And likewise, you know, when the servers want to respond, they'll respond back here through the router and then down to the computers. And that's the same for any of these devices on the network. And we can also enable these users with the appropriate configuration to talk out to the internet. You know, we can go from these users to this router.
So suppose, say, for example, in simple language, which I explained in my slide deck also about the communication subnet, right? Same is the case they are talking about. These are all different networks. They have shown two different networks. And if suppose, say, for example, one computer from network B wants to talk to another server or any computer from another network A, then it can go through this router. You can see the red dot, and then it can reach to the particular machine, right, in the other network.
And then we can jump to this router and then out to the internet. Okay, so hopefully that gives you a bit of an understanding of.
So from one machine to the router, router to the router, and then to the internet. Similarly, here in the slide also, you can see that from one host machine to the router, to the router, to the router, and then to the other machine, or maybe internetwork. Right? So that's this is all about all different types of networks, right? Yeah, wireless networks are of again two types. Wireless networks can be divided into three main categories: system interconnection, wireless LANs, and wireless WANs. Okay. System interconnection, we know they are basically personal area network again. We can use wireless technology to interconnect our system like wireless mouse, wireless keyboard, wireless personal digital assistants. Bluetooth is also a wireless technology that would allow all sorts of digital devices to talk to each other just by being close. The only thing is they should be close by. Wireless LANs, computers and the printers can connect to the network with a radio communication link. We have seen what do you mean by radio, microwave, all these transmissions. Okay, so there is usually some central access point or a base station where the radio connections are converted into the wired connections. The computers may also be able to talk directly to one another if they are close enough, right? So that is wireless LAN. Portable phones, Bluetooth is a wireless LAN. It works on the same frequency. Wireless is great for the older homes you don't want to wire, and laptops that you want to be able to move around, right? So that is where you can use wireless LANs. Cell phone networks are a good example of wireless WANs. So cell phone network is the wireless WAN. We are on our third generation of wireless WAN. That is, there was analog voice, digital voice, now digital voice and data. Do you know what is 2G, 3G, 4G, and 5G? Anyone knows? What is this 2G, 3G, 4G, and 5G?
Types of network.
Generation
Are you sure?
network.
What is 2G, 3G? ये क्या है?
Network speed, madam.
Ma'am, network
These are different generations of
Okay, what does G stand for? What does G stand for?
generation.
Correct. Is it used in computers or it is only used in mobile phones?
Primarily connected with mobile phones, because initially it was voice, then became voice and messages, then became 2G, then voice, message, and image became 3G. And then when you add videos, it becomes 4G.
Correct. And 5G?
5G is very high speed networks.
Multimedia, high speed multimedia, correct. Multimedia, voice and audio, right?
Yes.
Correct, very good. So that is, these are all generations, and of course the speed is also associated with it. Earlier generations, email also was not a part of it. It was only voice calls, and use digital signals instead of analog was the second generation. Okay, first generation was just like, I mean, we don't even count it. It was only analog. So second generation was only digital signals instead of analog. And that at that time we used to have SMS and MMS. SMS and MMS are from second generation. Okay, and it definitely provided better voice calls, but there was no email or data transfer rates were not increased. Okay, so broadband came into picture when it is 3D. Okay, 3G is nothing but third generation, wherein mobile telecommunication played a very important role, and the network architecture also got improved. The increased bandwidth, data transfer rate was better for 3G, right? Of course, you want to have more bandwidth, more speed, you have to pay more, right? Then fourth generation, ad hoc and multiple networks, scalable networks, better support to the interactive media, voice and video, right? High capacity, high speed, and low cost. Nowadays, you can see networks are getting cheaper, right? And the fifth generation, that is totally dependent on the radio bands, right?
And also they come up with the fact of the most battery backup, no, something.
Correct. Battery backup, not exactly battery backup. It may come up with the long lasting batteries.
Yes, for all
The
this
use of
function.
battery will be more optimum.
Yes.
Right. So that is where, if you remember, optical fibers, they have different modes, multi-mode and everything. So that will use the same bandwidth in multiple ways. Multiplexing will be frequency division. So it will give you more and more speed, right? So that was about, this is a very generic information, general information, which you all should know when you say 4G 5G matlab kya hai, right? I hope it is clear now.
Yes.
Home network. Yeah, home networks, we have seen a lot about home networks. Many of us have them already, multiple computers all connected. What about the connections to phones, entertainment systems, infotainment systems, appliances and other devices, right? How practical is the home network? I have already shown you a video in the first session itself. Right? Will people pay so that their toaster can talk to their fridge? Obviously. People will pay if sitting at home, I can operate all my devices at home, right? Sitting at office. Right? Internetworks is the internet is the collection of interconnected networks is called as internetwork or internet. Connections are usually made through gateways that can provide gateway is another device like router. Okay. You must have used the term payment gateway, right? So gateway is can provide a transition between the two different technologies. So Axis Bank person can GPay to ICICI Bank person. That is where in between payment gateway is used, right? Just like passport. If I want to change my country or pass into some other, go into some other country, I need a passport, right? So that is gateway. So gateway is nothing but a translator who can translate between different technologies and topologies. An internet network is formed when the distinct networks are connected. So that is called as internet. Okay. Very quickly, subnets we know. Now we'll talk about wireless networks. Write down only first point, 3 categories: system interconnection, wireless LAN and wireless WAN. Very quickly note down in your notebooks. Done. Write down about system interconnection, wireless LAN and wireless WAN. Done? Done? Write down about wireless LAN. Yeah, you can write this. This is a good example. Yes, finished. Home networks we know. Just write down about internetwork. So we have learned the fundamentals of network so that we can start with the crimes tomorrow. Let me know once you finish.
Finished, ma'am.
Yes, very good. So tomorrow what we are going to see is different types of attacks and security concepts. So our cyber security crime starts from there. Okay, cyber crime, cyber security, all these things will start from tomorrow. So tomorrow, so that is what is the uh, objective of designing module 1. Module 1 should, with the help of module 1, you should be able to have a clarity about what do you mean by network and introduction to crime, right? So that is what is module 1 is all about. So any queries you can tell me. Okay. No, the session is on, Brunma, you are right. The session is on Friday. Yes, tomorrow we don't have a class. The session is on Friday. So we will be meeting on Friday now, 2:30. Friday is the last day. I'm going to show you different scenarios of crimes also. What exactly cyber crime, right? So no technical, like Pradnya and few more students who are especially from different backgrounds, they had few challenges in understanding the technical concepts. But now technical thing is over. Okay, it will be all about crimes and how you should be aware about the cyber security as such. Okay,
Okay,
that
ma'am.
will be, yeah, that will be studying on Friday.
Okay, ma'am. Thank you.
Thank
Yes.
you, ma'am.
Yeah. So any queries, you can put it into the chat or you can ask. Otherwise, you can leave. Session is over, you can leave.
Okay, ma'am. Thank you.
Yes, thank you. See you on Friday.
Thank you, ma'am.
Yes, see you on Friday.
Thank you, ma'am.
Yes, anybody? Any queries? You can sign out, all of you.
काय माहिती
हॅलो हॅलो
Yes, Mayuri. Yes, Mayuri.
मॅम आता तुम्ही जे काही लेक्चर घेताय त्याच्या नोट्स किंवा आम्हाला पीडीएफ स्वरूपात काय असं भेटेल का?
हो, फ्रायडेला. आपलं झालं ना लास्ट लेक्चर की.
हो ठीक आहे. थँक्यू मॅम.
वेलकम.
Excuse me, ma'am.
Yes, Priyanka.
Yes, ma'am. Good afternoon. Will we be having any MCQ pattern examination for the same?
I won't be the right person to tell you this, Priyanka, because that is done at the institutional level.
Okay.
I am not a part of your institute. I am just alumni who is conducting the sessions as a guest faculty.
Okay, okay. So, ma'am, just to request, do you have any sort of questionnaire or any MCQ pattern that you can refer us?
I can provide you the notes.
All right, all right. Thank you.
Yeah.
Thank you, ma'am. Have a good day.
Yes. Good day. Bye bye.
Bye.
Hello. Hello. Hello? Hello?